Hello friends, in this video we are going to take up some very important questions from the chapter Carbon and its Compounds for class 10. These questions are really important for your class 10 board exams. So just ensure that you practice these questions thoroughly so that you can attempt them easily for your exams. So let us begin with the first question. How can you differentiate between saturated and unsaturated compounds? In my previous videos, I have discussed the chemical properties of carbon compounds. Over there, I told you the difference between addition reaction and substitution reaction. So that very property is the difference between, that helps us to find the difference between saturated and unsaturated compounds. The test is known as bromine water test. So using this bromine water test, we can find out whether the given compound is saturated or unsaturated. Saturated compounds do not undergo addition reactions, whereas unsaturated compounds undergo addition reaction. Suppose I take up the example of ethene. Ethene, it contains a double bond, so it is an unsaturated compound. When we add bromine to it, or if we add bromine water to it, what will happen? This double bond breaks, forming two single bonds, so that the valency of carbon is satisfied, and these two bromine atoms, they are added over here like this. So this becomes 1,2-dichloroethane. This is 1,2-dichloroethane. But if you add bromine water to a saturated compound, for instance, if we take ethane, it is CH3 single bond CH3, and we add bromine water to it. Since this compound is already saturated, it will be no reaction. Because the compound is already saturated, there is no place for addition to take place. So it will be a no reaction. So on the basis of this test, we can distinguish between saturated and unsaturated compounds. Saturated compounds, they do not react with bromine water. So the color of bromine water remains brown only. Whereas unsaturated compounds, they react with bromine water and they decolorize it. So if you get a question in your exam, how will you distinguish between a saturated and an unsaturated compound? You just have to write that unsaturated compounds decolorize bromine water, whereas saturated compounds do not. So this is how we can distinguish between saturated and unsaturated compounds. The second question that I am going to take up is, how can you differentiate between an alcohol and a carboxylic acid? The same question can be asked in another way, like how can you differentiate between ethanol and ethanoic acid? In either way, the answer remains the same, because ethanol is an alcohol and ethanoic acid is a carboxylic acid. There are three ways by which you can distinguish between the two. First is the most common, that is the litmus test. So over here I will be making a table. Ethanol versus ethanoic acid. The first test is litmus test. Ethanol does not react with litmus. So if I write litmus test, for ethanol it will be no reaction or no change in color, whereas ethanoic acid turns blue, litmus red. Because ethanoic acid is an acid, although it is a weak acid, but acids have the property that they turn blue litmus red. Whereas ethanol is an alcohol, it is neutral. It does not have any effect on either blue litmus or on red litmus. The second property is KMnO4 test. The natural color of KMnO4 or potassium permanganate is pink. So, in the chemical properties, we have studied that ethanol reacts with alkaline KMnO4 and forms ethanoic acid. So, ethanol decolorizes a solution of potassium permanganate, whereas ethanoic acid does not, so it will be no reaction over here. Ethanoic acid does not change the color of potassium permanganate solution. The third test that we can take up over here is sodium bicarbonate test, NaHCO3 test. Ethanol or alcohols, they do not react with sodium bicarbonate, whereas ethanoic acid, it reacts with sodium bicarbonate. We have done this property in the chemical properties of ethanoic acid, and it gives off carbon dioxide gas, so an effervescence is produced. So it gives effervescence with the evolution of CO2 gas. What is effervescence? Effervescence is the sudden coming out of a gas. Like if you shake a cold drink bottle, the liquid, it comes up all of a sudden. That is what is effervescence. So in this case, effervescence will be produced because the carbon dioxide gas, it will come off very quickly from the reaction mixture. So these three tests can be used to distinguish between ethanol and ethanoic acid. These are the chemical tests. On the basis of physical properties, both of them are liquids, but if you want to distinguish between them, ethanol is bitter in taste, whereas ethanoic acid is sour in taste. That property can be used. Let us take up one more example. My question is, why does acetylene burn with a sooty flame? This is my question. Now again, we have discussed this in the properties of carbon compounds, that saturated carbons, they undergo complete combustion because they contain a larger amount of hydrogen as compared to unsaturated compounds. Since acetylene is unsaturated, it is an unsaturated compound. What is the formula of acetylene? It's CH triple bond CH. It is also called ethylene. The IUPAC name is ethylene. Acetylene is the common name of ethylene. Since it is an unsaturated compound, it does not undergo complete combustion, and that is why it burns with a sooty flame. One more question of the same type. Kerosene does not decolorize bromine water, whereas cooking oil does. Now I expect that you should know the answer to this, because this is what I have discussed just now with you in the previous question which I took up just before I erased the board. So kerosene does not decolorize bromine water. What does this mean? Which compounds, what are the compounds which decolorize bromine water? They are unsaturated compounds because bromine gets added to them. So if kerosene is not decolorizing bromine water, it means that it is a saturated compound. So kerosene is actually a mixture of, it is a mixture of saturated compounds. That is why it does not react with bromine water. It is a mixture of saturated compounds. Whereas cooking oil, it is a mixture of unsaturated compounds. That is why kerosene cannot decolorize bromine water, whereas cooking oil can. So I hope these questions are clear to you. We'll be taking up more questions in the subsequent videos. So keep watching.